Thank you for the opportunity to present today. I'm Dr. Joseph Kiter, an assistant professor in the School of Modeling and Simulation and Training. My research overlaps the boundary of computer science, architecture, and human factors in engineering, looking to produce greater knowledge at the intersection of these disciplines. I focus on transdisciplinary problems, such as looking at the impact of urban design on humans. The main premise of my research is that blending these interdisciplinary research boundaries on this transdisciplinary problem will produce a more informed design process to better inform buildings and people. I also teach what I preach, offering courses from students in a mix of backgrounds, teaching the theoretical foundations of simulation techniques, a VR/AR course, and a research practicum course in the Modeling and Simulation graduate program. First, I wanted to briefly talk about the School of Modeling and Simulation, since that's a concept that might be foreign to some people on this talk. And people might want to understand how it fits into the Institute and the Simulation graduate program. Along with my colleague, P.K. Douglas, I was one of the first two tenure-earning hires at the School of Modeling and Simulation and Training. The school was established in 2018 based on the impact of the scale and excellence of the Institute of Simulation and Training and the model and graduate programs here at UCF. Since 1982, IST has been one of the top 3 research-funded units at UCF, currently hosting only 46 core researchers. IST consistently gets broad levels of funding from NASA, DARPA, NEH, DoD, USDA, FAA, to name just a few funding agencies. Since 2001, the M&S graduate programs have educated 552 leaders in modeling, simulation, and training in the Orlando area. These programs blend understanding of people, process, and technology to weave together theoretical foundations for many disciplines to solve wicked problems. And faculty from across the campus have guided our students. Together, these two units form the IST School of Modeling and Simulation and Training, which is currently being directed by Dr. Fuzzy Wells. SMST reports to the College of Graduate Studies under the direction of Dr. Liz Klonoff, who literally does the job of 2 people. Most of you know her as the Vice President for Research, however, she is my Dean in the College of Graduate Studies. Based in Research Park, right at the south of campus, SMST research labs provide the foundation that we build our sustained excellence, making us leaders in advanced virtual environments, AR, VR, LiDAR capture, computational cognition, human factors and performance. We solve some of the most challenging problems that face society today. SMST is a great organization, and if you're looking to collaborate with the school in general, please reach out to myself or Dr. Wells, and we'll happily partner with you looking for future collaborations. Switching gears back to my research, I would like to present a few projects I'm currently tackling. And I chose these projects to demonstrate that I seek and thrive on collaborations. And these are potential areas I'm looking for collaborators on. The first project is how emerging augmented reality and building information modeling technologies can be integrated to increase human performance. I think all of us at some point tried to upgrade something in our house or apartment, from hanging a picture to a large upgrade of a pipe or electric conduit. Imagine if I could take that uncertainty out of that task. So before you went to cut into that drywall, worrying you're going to bust a pipe or hit a beam or something, we are able to provide situational awareness so that you can conduct a complex problem-solving task in the built environment by giving you the data and visualization you would need to succeed at that task. Our project is currently funded by the NSF, and it blends together 4 very interdisciplinary researchers, from having expertise in learning science and problem solving, to capturing buildings with Dr. Walters, to having one of the foremost experts in 3D user interfaces in Dr. Laviola. We chose retrofitting since America is basically out of space. So let's think about UCF for a second to ground this in something practical. A lot of you have heard the common joke, UCF stands for under construction forever. However, I'm going to argue we're at forever. As you walk around, you'll notice there's little space to build. Buildings are rapidly aging at the same time. So the choice America faces, just like UCF, is do we tear down the structure, like Trevor Colburn Hall, and build a new structure? Or do we retrofit an existing space like the Biological Science Building to improve energy efficiency and occupant performance? Retrofitting typically produces less waste, is cheaper, and embodies less carbon than a tear down rebuild. So what we have been working on recently is collaborating with UCF facilities to plan the retrofit of the biological science building. Now, I just found out that there's a basement in Florida, and one of the buildings that have them is the biological science building. Here's a scan of a LiDAR scan of 31 LiDAR scans together to form this virtual environment conducted by my colleague, Dr. Walters in CoPI. What we're doing is digitally constructing a virtual twin of the building using LiDAR captures to provide building and modeling information to provide data to architects and engineers that are working on this project. Now, in the before state, as a lot of researchers have noted, we were able to travel around freely. Right now, this project has an architect in one location, a design engineer in another location, and facility members here in Orlando. Due to COVID, this digital twin will allow everybody to get together in one virtual space so that they can plan this retrofit in a remote collaborative way. We can provide a space where remote participants can use VR and on-site workers can leverage AR to have one collaborative space to do this $9 million retrofit to improve arguably the worst building on campus in terms of energy performance and occupant comfort and satisfaction. Another project I want to briefly show is joint work with Leidos and Cornerstone Solutions. Now, my training includes grounding in computer science with specialty in computer graphics. I don't always use these skills and abilities to make pictures for movies and games. I leverage my interdisciplinary knowledge to build first principle accurate spectral simulations. This requires me often to go up on rooftops to capture spectral light down to the ground to understand complex spectral reflections, absorption, transmission, and other optical properties. This physically based methodology provides accurate inputs to materials and light sources for spectral simulations. This project took advantage of this work to simulate different sensors to train drone pilots. Often we find a lot of real-time applications fake infrared sensor simulations. So they build them up with a series of black and white textures, and they don't understand that materials perform differently in different spectrums. Our work builds a correct spectral light source directly from the sun through measurements and machine learning, and materials that we captured to understand the bidirectional reflectance function to let the Air Force pick the spectral range for their sensors based on the operating parameters of the drone and run an accurate real-time lighting simulation so they can create their own training scenarios. This simulation is able to provide representations of signatures that the real world would actually see in this IR spectrum range. We leverage open source tools like the Unreal Engine to make this run in real time and to democratize the process. This way, the Air Force can easily build their own mission plans and training scenarios and don't have to rely on contracting out for every single change. This work has future applications to train machine learning models, as self-driving cars tend to integrate more IR sensors, and drone applications for common tasks tend to integrate more IR sensors. We can produce synthetically a training set of machine learning capable ready images that are segmented to allow these new deep learning algorithms to train with a realistic data set that can be produced from all different angles, from all different conditions, so that when it goes into the real world, it can have applicability and be trained and learn in a very specific way. Now, I'm always looking for collaborators to help. I can help you by providing technical expertise in modeling and simulation. I have unique skills and abilities in VR, AR, computer graphics, building energy modeling and design. And you can help me understand humans. You know, being a computer scientist, theoretical foundations on why humans do what they do always escapes me, but my research involves humans in the loop in some form. I also look for technical expertise in mechanical engineering and electrical engineering to better understand the system of systems that are buildings. Since these are complex processes and complex phenomenon, I like to derive with people in civil, people in mechanical, people in electrical, so that we could realize some of these designs to produce something greater than its whole. Lastly, I'd like to thank all my students. Without them, I would be absolutely nothing, since I stand on their shoulders, and all the wonderful collaborators and funding agencies that have gone into my work to realize the designs, to blend everything that I do to do and work on these wicked transdisciplinary problems. Thank you, and I'll happily answer any questions you might have on my research work or the School of Modeling and Simulation and Training.